Hello, everyone, and welcome to the final podcast for day 17. We went a little out of order in these objectives. So, in this podcast, we're going to talk about the final points from Objective 1, mainly the ones related to cancer. So, these last 4 points here. So, let's go ahead and get started. In the last podcast, we talked about how tumor suppressor genes and oncogenes, proto-oncogenes, can control the cell cycle, and how when they're mutated, they can cause the cell cycle to go out of control and go faster than it should, ignoring any mutations that they may be passing on, and how that can then lead to cancer. So I think it's really important that we talk a little bit about cancer. It's a disease that certainly, if it hasn't affected your life, it will at some point. So let's talk about it a little bit here. All right, so when we start thinking about cancer cells, it's also good to think about what normal healthy cells look like. And I'm going to do my best here to do a drawing here of what normal cells look like. And so what I'm going to do here is these are going to be normal. And I hate using the word normal, so let's use healthy. These are healthy cells. And I'm going to try to draw them kind of like this. Just all about the same size, touching each other, very regular shaped. These cells, well, let's just write a few things here. They're communicating with each other. They're touching each other. It's another way of saying that. They're exchanging nutrients. So let's write something regarding that because that's pretty important. Exchange nutrients between the cells. So they're in constant communication with each other. They share these nutrients with each other equally. They all look the same. And so, let's see. Let's just write looks same. And so what I'm talking about, like if you're talking about, say like a pancreatic cell, pancreatic cell, there's all kinds of different kinds of pancreatic cells. But let's say like these are our beta pancreatic cells. You don't need no beta pancreatic cells, but they're all going to look the same. Now, other pancreatic cells, they may not look the same, but the same cell types, they're going to look the same. Oh, what did I write there? Let me just scribble this out. I made a mistake. Look same. The cells look the same. And unless we're talking about blood cells, and we're not here, let's just name these. Let's call these lung cells, okay? These lung cells, they're not moving, they're staying put. So let's say they are stationary. That's probably a good enough word to use here. They're not moving around. They don't like jump into the bloodstream and move to other parts of the cells and set up lung tissue somewhere else. I forgot how to spell stationary. I got so excited about talking about what the cells are doing here. So they're stationary, they don't move. Another thing, you can't really see here. We should list it here as a characteristic of the healthy cells, and that is that they have cell cycle control. Actually, I'm going to write cell growth controlled, and that means that their cells are regulated by the cell cycle, but it also means that they fit in a confined space within the tissue of the lung, and they don't grow anymore. They form this nice smooth structure of the organ. They stay within that confined space. And one last thing is that these cells have a finite life. When I say finite, I mean that they don't live forever. They will divide a very specific number of times and then they're done. Okay? We'll talk later, maybe, probably not in this class, but when you hit genetics or cell biology, you'll learn why it's important that cells don't live forever. Next, let's think about what cancer cells look like. Later, I'm going to want to differentiate what the difference between a benign tumor and a malignant tumor. But for now, I'm just going to call it cancer. But you should tuck in the back of your mind here that all cancers are malignant. And then I want to tell you in a little bit what distinguishes this from a benign tumor. And so what I want to do is I'm going to draw some of these cells we have over here. These same kind of liver cells. I'm sorry, lung cells. And I'm meaning to draw these about the same size over here. Got a little carried away with this one up here. But what might happen is you might end up with a cell that begins to grow a little faster than the other ones. I'm going to put these in red. Initially, they're going to look pretty similar to the other lung cells. But because their cell cycle has just lost some of its control, probably because of a tumor suppressor gene mutation or an oncogene mutation, they begin to grow faster than the healthy cells, the ones that are in black. They're still there, these black ones, so I'm going to draw a couple of them here. So this is very common in the early stages of a tumor, that they begin to grow faster than the other ones, than the healthy ones. Let's go ahead and draw something next here. I'm drawing these here, these cells. Again, they're supposed to be about the same size as these others. But now what starts to happen is, so now these cells that have already begun to grow out of control, they will start to gain more mutations. And now what's going to happen is they're going to start to form a little different. They're going to start to shape a little different. And I'm intentionally, well, maybe I won't do that yet. So I'm trying to draw these a little different because now they don't look like a lung cell anymore. And they're kind of growing out of the confines. Because remember over here I said they look the same, they all look the same. Now they're starting to look different. And I said they communicate with each other over here, but now they're starting to kind of move beyond their normal realms here. And they're not really touching. This one's still touching, but they're not touching anymore. They're still touching with each other. They're communicating with each other. But the other cells, the healthy cells, are now becoming even fewer in number, and they're not touching the cancer cells. This is significant for two reasons. Well, let's see, maybe I'll come up with more, but at least two reasons. These healthy cells aren't communicating with the cancerous cells to signal them to stop growing or to bring along the immune system. So they're going to keep growing faster and faster. And also I want to make one more point here. In order to get this first stage up here that we're looking at, you probably needed plus one mutation. To move to this stage here, you would need more than one. And I'm just going to kind of make a bit of a guess here, but like 2 to 4 mutations here to get them to change their shape, to begin not communicating with their neighbor cells. Now, I didn't say it on the left where the healthy cells are, but every now and then you're going to get a cell that divides and it gets one of these tumor suppressor mutations in it. What will happen though is that the immune system, let's draw an immune cell here. We're not going to go through all of immunology just to explain this concept here, but every now and then healthy tissues will have a rogue cell that starts to behave improperly. And what happens is we have an immune system cell. I'm going to draw it like a little Pac-Man because I don't know if that's how I'm going to do it. It's going to come along here and it's going to digest and destroy these cells that are not behaving the way they should. So the healthy cells have a way, as I said here somewhere, maybe I forgot to say it, but they have they're immune sensitive, these healthy cells. The immune system will respond to poorly behaving cells. sensitive. Okay, that's really important. Now over here, you still have your immune cells, but they can't find these. They've kind of hidden themselves. There's a lot of clever ways that the cancer cells evade the immune system. Now, one thing that's not clear here, or maybe not clear just by looking, is that as these cells begin to grow, these cancer cells, and you're still getting the black cells growing here, the healthy cells, but as they continue to grow, they're taking more and more of the nutrients away from these healthy cells. And so that's another detriment placed on these healthy cells. So let's go over a few things that we've said so far that's associated with these cancer cells. And I'm going to list them, well, I'll list them here. So there's no growth control. The cell cycle has been changed. They're growing out of control. They look different than the healthy cells, and they no longer function like the healthy cells. These lung cells have lost the ability, these cancer growing cells have lost the ability to behave like a lung cell, and they're consuming more nutrients than the healthy ones. I'm just going to go put consume and then the greater sign and nutrients. So those are some of the things we've said about this. Oh, one last really important one, right? They're beginning to evade the immune system. This is really a bad situation. Okay, now I do want to change something here. This is kind of a work in progress how I was going to present this. And I want to change something because really what I've described up to this point is what we might call, I'm going to get rid of the word malignant. Because really at this point here, I'm going to introduce the term benign. I said I wasn't going to talk about it until later, but I want to talk about it now. Really, a benign cell does all of this. It starts to grow out of control. It begins to not communicate with the other cells. It's all doing that, just getting bigger and bigger, this mass of cells. And so we would call this a benign tumor. So that's an important distinction. I should have thought about that with the direction I was going, but I think we can fix it now. Just cross out malignant. Really what we're talking about here is still a benign tumor. Now, it has the capability of becoming a malignant tumor. And how does it do that? Well, let me go back and say one more thing about benign tumors. Benign tumors, what makes them benign is that they stay within this localized region of the lung in this case. They don't leave the lung. It's just this big mass of cells in the lung or in whatever tissue the tumor is growing. Now, what these cells will do, and this is going to require some additional mutations. Let's say we're going to get about, in this whole process, another 2 to 4 mutations. These cells now, they will send out chemicals. Don't worry too much about it, about me saying they're sending out chemicals. But they are sending out these chemicals. And you may have a blood vessel. I'm going to draw it in blue just so it looks different than these red cells here. So there's these blood vessels coming by. They're not really in touch with these tumor cells, but these chemicals that get sent over here to this blood vessel causes this blood vessel to diverge and grow towards the tumor. And now all of a sudden, this blood vessel that was pretty far away, relatively speaking, from the tumor now is engrossed with all the vascularization from this original blood vessel. Now this is important for 2 reasons for the tumor cells. The first, this also helps bring in extra nutrients and gases for these tumor cells to continue to grow and survive. It also provides a vehicle, a means for these tumor cells that were currently benign to escape their original location. So now these cells have left. And at this point here, once they've have left this primary site, we now call them malignant. Once they've left the primary site, have entered into the blood vessels, and now are moving around the circulatory system or the lymphatic system, they now have become malignant. Meaning, and another word we should say here is metastasize. We say that these cells have metastasized. M-E-T-A-S-T-A-S-I-S. Metastasis. And this just means the cells have left the primary site. And when they do that, again, we're now talking about malignancy, and we're talking about cancer at this point. When it's benign, we don't call it cancer. It's not until it becomes malignant. Now, once they're here, what's going to happen? So this blood vessels, just like our circulatory system, they go all around their body. And let's say it passes by the lung. We're at the lung, the liver. So let's draw a fake liver here. Okay, so here's our liver. It had been fine up until this point, and now the blood vessel is going to move right to it. And as it does this, to bring in the necessary oxygen and nutrients and to remove the carbon dioxide from this liver, it's also bringing in these bad cells, these cancer cells. And now they're going to be in this liver, and now they're going to start to grow. And before you know it, they're going to start to grow really fast. They're going to grow faster than the healthy cells. And eventually they're going to start outcompeting the liver cells now for nutrients. And before long, this tumor, this cancer, if it's not caught early enough, we're going to find that this individual has cancer in their lungs and it's metastasized to their liver. All right, so I want to go over some things because I kind of changed some terms as we were going through, and I apologize for that. So over here, just to review, healthy cells, we're talking about the lung here. They communicate with each other. They exchange nutrients with each other. They grow within a confined space. They don't move from tissue to tissue. They have cell growth regulation. They have a finite life. I forgot to mention that over here. These cells, these tumor cells, they are what we would call immortal. They never die. In fact, we have cell line cultures that have been growing for over 60 years. They live indefinitely. They don't die off like a normal cell does. And the healthy cells are sensitive to the immune system. The immune system will come along and find these poorly behaving cells and get rid of them. Now, initially what's going to happen is you're going to get a cell cycle mutation. And that's going to allow this cell to start growing faster than its neighbor cells. And then it's going to start to accumulate more mutations, maybe 2 or 4 more mutations. And now the cells start to have a different shape. They start to kind of move away from the healthy cells, as we see here. They're no longer communicating with them. They have hit a situation where the immune system doesn't recognize them, so the immune system doesn't try to kill them. Now we might get, and at this point we're still, again, talking about a benign cell. This is where I kind of changed terms on you. We're still talking about a benign tumor. A benign tumor grows big, it forms this big mass, but it stays in the site of where it was primarily formed. Now a few more mutations come along, maybe 2 or 4 more mutations occur. And this growing tumor now will recruit blood vessels to it. And when it recruits these blood vessels to it, it provides nutrients to the growing tumor, but it also serves as a way for these cells to leave. And once they've left, then we've hit a brand new ball game here. A bad one. This is when the tumor becomes malignant because it has metastasized from its primary site now to a new site, the liver. Now what I want to do is show you a couple pictures of some tumors, and then I also want to show you a quick little video. So over here we have a melanoma, a skin cancer, right here. And you can see how it's growing in a pattern very different than the healthy cells on the outside of it. Okay. They look different. They have different colorations throughout it. You can't really see here, but this would be raised up above too, which is another big sign that it's cancer. So these here are actually metastasized cancers. Once they get to this stage, they have metastasized. But this is a liver. And what's happening here is this red tissue here, this is the healthy liver. And you can see how all of these kind of wider areas, they look markedly different than the healthy tissue. And that's because they have gained many, many mutations. And now they are not functioning as liver cells anymore. They're stealing all the nutrients away from the healthy cells. And now this liver is going to be failing. Well, this liver is no longer in the person, but before they removed it from the person, this liver was failing. At this advanced stage with all these tumors, I'm not a cancer physician, but I'm pretty confident that these tumors have metastasized at this stage because of the advanced stage that this appears. Next, I want to show you this video. Now, the first part of well, let me tell you what these cells are. These are human breast cells. These are specifically cells that form the mammary ducts, the ducts that transport milk out of the breast tissue. And initially what we're going to show you are healthy cells. And these healthy cells, you're going to see, I'm going to go and start the video here, will divide in a very regular pattern. See how they're dividing? Pretty regular and about the constant rate. And they're going to show a diagram here of just showing how it should appear with this nice duct in the middle. Now what we're going to see, I'm going to hit pause. We're going to see a cell that has a BRCA1 mutation in it. This is the tumor suppressor gene that, when mutated, will cause the breast cells to grow. In fact, BRCA1 was one of the very first tumor suppressor genes identified for breast cancer. So let's take a peek at what's happening here. You're going to see when they start to show them how fast. Oh, I have one more point to make. They did not change the speed on this. They're set at the exact same speed of growth. So they didn't speed this up to illustrate a point. This is growing, the clock is the same. And you're going to see how much faster these are dividing. See how fast? Remarkable. And in addition to growing really fast, you can see that they are not forming these same consistent cell shapes. They're forming these large masses of cells that will eventually form a lump. Okay, will form that. Oh, they're going to show it again for us. Growing really fast, and now they're going to form this huge lump. All right. And just to recall, right, that's so much different than what we see here with them growing, the healthy cells growing without a mutation. If you have any questions, please come see us. We'll be happy to answer any questions you may have. All right, good luck, and we'll see you in class. Bye.